For months, astronomers tracked it as just another faint smear of light, an icy visitor passing through the outer darkness, obeying gravity, following the rules we thought we understood. It had a name that sounded routine, almost boring: 3IATLAS, another interstellar interloper, another line in a database. Then the trajectory changed. Not by much, not enough for headlines at first, just a subtle deviation, a bend in its path that shouldn't exist if everything we were taught was complete. But to the scientists watching the data scroll in real time, that tiny shift rang alarm bells, because objects like this don't simply change course, not without a reason. And this reason appeared to point inward, toward the inner solar system, toward Earth's neighborhood. NASA scientists were careful with their words. They always are. No talk of danger, no dramatic warnings, just phrases like unexpected acceleration and non-gravitational forces. But behind closed doors, a deeper unease settled in, because this wasn't the first time an interstellar object had behaved strangely, and history has a way of repeating itself, only louder. We like to believe space is predictable, that cosmic objects are ancient, dumb, and obedient, rocks and ice following equations written centuries ago. But 3IATLAS is challenging that comfort. Its motion hints that either something is acting on it or something inside it is acting back. This is where the story fractures. Because if this course change is real, if it holds up under scrutiny, then one of two things must be true. Either our models of interstellar physics are missing something fundamental, or we've just witnessed behavior that doesn't fit neatly into the category of natural object. And that leads to a question few scientists are willing to ask out loud, but many are now quietly considering. What exactly is 3IATLAS, and why did it turn toward us? For most of our lives, we were taught a simple, comforting story about objects like this. Comets, asteroids, interstellar wanderers, they are relics, leftovers from planet formation, frozen debris drifting through space for billions of years, pulled only by gravity and nudged gently by sunlight. Their paths, we were told, are predictable, calculable, safe as long as we do the math correctly. In school textbooks and documentaries, space follows rules. Newton gives way to Einstein, and with those equations, humanity learns to forecast the heavens. If an object enters the solar system, scientists can trace where it came from and where it's going. Deviations are rare, and when they happen, they're easily explained. A comet heats up, ice sublimates, gas vents out like a natural thruster. Mystery solved. This framework works remarkably well. It's why we can land probes on comets moving tens of thousands of miles per hour. It's why space agencies can plan missions decades in advance. It's why most astronomers initially shrugged when 3IATLAS was first detected. Interstellar object. Interesting, yes. Unprecedented, no. We've seen this before. In 2017, Oumuamua passed through our solar system, the first known visitor from another star. It was strange, but still it fit mostly within accepted physics. In 2019, 2I/Borisov followed, clearly a comet, clearly natural. By the time 3IATLAS appeared, the narrative was already written. Another ancient traveler passing through, never to return. And that assumption mattered. Because once scientists decide an object belongs in a familiar category, every observation is filtered through that belief. An odd data point becomes noise. A discrepancy becomes an error bar. The model is trusted first, the anomaly questioned second. But here's the quiet truth about science. Models survive only until reality pushes back hard enough. And with 3IATLAS, reality may have just done exactly that. If this object is behaving like every other icy rock we've ever studied, then its path should make sense. It should obey expectations. It should not surprise anyone. So why did it? The discomfort began with a spreadsheet. As more observations came in, astronomers noticed that the predicted path of 3IATLAS and its actual motion were no longer lining up. At first, it was subtle, fractions of a degree, barely worth mentioning. But in astrophysics, tiny discrepancies are often where revolutions begin. Gravity alone couldn't explain what was happening. When scientists accounted for the sun's pull, the planet's influence, even relativistic corrections, the numbers still refused to behave. The object appeared to be accelerating in a way that didn't match its brightness, its size, or its apparent composition. In simpler terms, if 3IATLAS were a normal comet, it should have been venting gas we could clearly detect, but the telescope saw almost nothing. No dramatic tail, no obvious jets, no clear signs of outgassing strong enough to push an object of its mass off course. This is where unease turned into genuine concern. Imagine throwing a stone across a frozen lake and watching it curve midair, without wind, without contact, without explanation. That's what this looked like to the scientists running the simulations, an effect without a visible cause. Some suggested hidden ice types, like hydrogen or nitrogen, sublimating invisibly. Others proposed unusual shapes, tumbling geometries, or extreme porosity. Each idea tried to rescue the old framework. Each required assumptions stacked on top of assumptions. And then came the most troubling realization. The direction of the deviation wasn't random. It appeared oriented, as if the object were responding to something specific in the inner solar system, as if the acceleration had intent or at least alignment, not toward the sun, as solar heating would suggest, but skewed, angled, purposeful. Physicists are trained to be skeptical of words like that. Purpose has no place in orbital mechanics, and yet, when equations stop explaining motion, language starts to drift toward the forbidden. This wasn't proof of anything extraordinary, but it was a crack, and cracks are dangerous because once you see one, you start looking for others. If 3IATLAS isn't behaving like a natural object should, what exactly are we missing? That question forced a shift, quiet at first, then unmistakable. Across observatories and research groups, scientists began revisiting assumptions they hadn't questioned in decades, not because they wanted controversy, but because the data left them no choice. When reality refuses to fit the model must change. This is how modern science actually moves. Astrophysicists began applying tools that didn't exist a generation ago: ultra-precise astrometry, long baseline tracking, machine learning systems trained to detect subtle motion patterns humans might overlook. When these methods were applied to 3IATLAS, the anomaly didn't disappear, it sharpened. The error bars shrank, the deviation remained. Some researchers compared the motion to radiation pressure, the force exerted by sunlight itself. For very thin, very light objects, photons can act like wind. This was once considered negligible. Now it had to be taken seriously. Others looked to thermal recoil, asymmetric heating, and exotic surface chemistry. Each explanation nudged physics forward, but none fully closed the gap. What changed most wasn't a single theory, it was attitude. After Oumuamua, the scientific community became more willing to say the quiet part out loud. Interstellar objects may not resemble anything from our own solar system. They form around different stars, under different conditions, with chemistries and structures we've never sampled. In other words, our expectations may be provincial. NASA scientists emphasized caution, but also transparency. Papers began using phrases like poorly constrained, non-standard, and requires further investigation. These are scientific red flags, signals that understanding is incomplete, not wrong but unfinished. And then something subtle happened. Instead of asking, how do we force this object into our models, researchers began asking, what kind of object would naturally do this? That inversion changes everything. Because when you stop assuming nature must behave the way you expect, you open the door to possibilities that were previously unthinkable, not fantasies, not speculation, but physics we haven't mapped yet. 3IATLAS wasn't just challenging an equation, it was challenging the boundaries of what we consider normal in the universe. And that made one idea, long dismissed as fringe, suddenly impossible to ignore. The idea is unsettling precisely because it doesn't begin with science fiction. It begins with engineering. For decades, physicists have known that it is possible to move through space without fuel in the traditional sense. A sail, thin enough, wide enough, can be pushed by light itself. Photons carry momentum. It's small, but over vast distances and long times, it adds up. Humanity is already testing this concept with solar sail spacecraft. Now imagine that same principle scaled up, or refined, by a civilization far older than ours. This is where the conversation around 3IATLAS becomes uncomfortable. Because its acceleration profile looks eerily similar to what you would expect from an object being pushed by radiation pressure, not violently, not abruptly, but smoothly, continuously, as if designed to respond to starlight. The radical idea is not that it's a spaceship barreling toward Earth. That's a caricature. The real hypothesis is more subtle and more disturbing. What if some interstellar objects are not natural rocks at all, but artifacts? Not active probes, not crude vessels, but dormant technology, debris, relics, things built long ago, sent drifting between stars, responding passively to their environment, like messages in bottles scattered across the galaxy. Harvard astrophysicist Avi Loeb was among those willing to say this publicly, not as a claim, but as a possibility worth examining. His argument was simple. If something looks engineered and no natural explanation fully accounts for it, science has an obligation to at least consider the hypothesis. 3IATLAS is not confirmed to be artificial. There is no signal, no transmission, no metallic reflection screaming technology, but its behavior occupies a strange middle ground, too coordinated to ignore, too ambiguous to conclude. And here's the part that truly changes everything. If even one interstellar object were artificial, it would mean the galaxy is not silent. It would mean that evidence of other intelligences isn't hidden in distant radio waves, but drifting quietly through our own solar system, unnoticed for millennia. Suddenly, the question is it coming for us? The question becomes far more unsettling. How many have already passed by, without us ever realizing what they were? If this idea feels uncomfortable, that's because it forces us to confront implications far larger than a single object in space. If 3IATLAS, or anything like it, represents a new category of cosmic phenomenon, then humanity's position in the universe subtly shifts, not dramatically, not overnight, but fundamentally. It would mean we are not just observers of a silent cosmos, we are participants in a much older story. Critics are quick to point out the dangers of overinterpretation, and they're right. Science advances by skepticism, not wonder alone. Extraordinary claims demand extraordinary evidence, and right now the evidence is incomplete. Alternative explanations still exist. Exotic ices, unusual geometries, physics we haven't fully modeled yet. But here's what cannot be dismissed. The anomaly is real. The trajectory change is measurable. The discomfort among scientists is genuine. And the fact that our best models struggle to explain the motion tells us something important, regardless of the final answer. It tells us that the universe is under no obligation to behave in ways that make us comfortable. This is how scientific revolutions begin, not with answers, but with persistent questions, the kind that refuse to go away, the kind that expose the limits of our knowledge. Whether 3IATLAS turns out to be a natural oddity or something profoundly unfamiliar, it has already done its job. It has reminded us that certainty is temporary. For centuries, humanity believed Earth was the center of everything. Then we learned we orbit the sun. Then we learned the sun is just one star among hundreds of billions. Each step didn't diminish us, it expanded our context. This may be another such moment. Not proof of anything beyond doubt, but a signal that the story is still unfolding, that our cosmic education is incomplete, and that the next chapter may arrive not as a message, but as a silent object drifting through the dark. At the beginning of this story, the question seemed simple. Why did 3IATLAS change course? But now, after peeling back the layers, the question no longer fits in a single sentence, because this object isn't just about trajectory, it's about perspective, about how much of reality we assume we already understand. 3IATLAS may turn out to be a perfectly natural interstellar object, governed by physics we are only beginning to model. That outcome would still matter. It would mean the universe is more diverse, more creative than our textbooks suggest, that even rocks between stars can surprise us. Or it may represent something far rarer. A relic of processes or intelligences we have yet to encounter directly, not a visitor announcing itself, but a quiet reminder that the cosmos has been evolving for billions of years longer than we have, that if others existed before us, their traces would not look like movies taught us to expect. They would look like anomalies. NASA scientists will continue tracking 3IATLAS, telescopes will refine its path, data will accumulate, explanations will sharpen or collapse. This is how science resolves mystery, not through fear but through patience. And yet, the deeper truth remains. Every time we detect something unexpected in the sky, we are forced to confront how small our window of understanding truly is. The universe does not reveal itself all at once. It whispers, it leaves clues, it invites curiosity, not certainty. So the next time you hear that an object from another star has entered our cosmic neighborhood, remember this moment. Remember how a slight change in course forced us to ask bigger questions than we planned to. Because the most profound discoveries don't arrive with answers. They arrive by reminding us how much there is left to ask. If this story made you pause, if it made you look at the night sky a little differently, stay curious. because the universe is not done surprising us. And somewhere out there, something else may already be on its way.